Thank you very much for the invitation for this very important training course. Q2, R2, Q14 guidelines were published in November 2023, and training materials were posted at the ICH site in July this year. The goal of the presentation is to help the audience to understand overall structure of the two guidelines and to help the audience to find points of or themes of their interest by presenting overall structure of Q2 and the Q14 guidelines and selected slides from the training materials. Outline of this presentation actually is following shown in this slide. The first overview of the two guidelines. The ICH Q14 analytical development guideline has this life cycle figure. Starting with the product development and initiation of the life cycle of the analytical procedure begins with the goal setting, which is the goal called as ATP is set in a technology-independent manner. Once technology is selected, development starts. During the development, risk assessment and experiments were conducted. Once the analytical procedure is drafted, then analytical validation is performed. After validation, the procedure can be used routinely, and during the routine use, continual improvement is very much encouraged. When changes become necessary, activities can go in 3 ways, shown in this slide. If product is changed significantly, you may re-evaluate or re-establish ATP. If proposed changes are not very large, you may qualify the change by existing knowledge, and in that case, experimental study might not be needed. Here's the slide in validation guideline Q2R2. This is another way to look at the structure of the two guidelines. The Q2 figure shows the analytical procedure life cycle by high-level description of the ICH Q2. So this actually, the figure or chart in ICH Q2 guideline is to link between development and the validation. The next is that the structure of training materials, which was published just recently, back in July this year, and my personal read suggestions for you. Next 2 pages is extracted from ICH training material. These 2 tables are called map of contents instead of table of contents. Then the map of contents actually contains contents, also linkage between the modules or module parts. There are 7 modules, starting with module 1. Module 1 is the same copy of the step 4 presentation for ICHQ2 and ICHQ14, which was published right after the finish of the 2 guidelines 2 years ago. Module 2 and Module 3 are for the fundamental principle and particular practical application of validation guideline. And the module 4 and the next page, module 5, are for ICHQ14. The far right, on your right, the column is linkage between the parts between modules. For instance, maybe I should, for instance, the MODR is actually explained in part A of module 2, and then you can find the other parts in the MODR. For instance, module 4, parts E, and the next page, MODR is the last part of example of module 7. So this, I hope this actually map of contents for more training materials is useful for you. Okay, next. This is the my personal read suggestions for you. This might not be only way to read and study about the 2 guidelines, but here's my personal suggestion. If you need only a very high level of understanding on the 2 guidelines, look at the training module 1, which is a high level step-by-step explanation of the 2 guidelines. But if you like to get the comprehensive and the detailed understanding of the guidelines, then pick the one of the 4 studies described in module 7. There are 4 case studies described module 7. Whatever you understand, just pick one of those and read corresponding descriptions, module 2, 3, 6. I think I'm telling you a very complex suggestions, but if you like to understand the 2 guidelines in detail, this may be the way to study these 2 guidelines. In any case, the terms or terminology definition is very important to understand the guidelines content. Terms actually used in the guidelines are mostly defined in each of the guidelines at the end. So clear understanding of those, check definition part first. The reason for this is the interpretation of those terms. Your interpretation may not be the same as the official definition by ICH guidelines. So then check definition first. So also, it is also important to understand the interrelations between the terms, the connectivity between those terms are also important. So then I prepared the slides, actually extracted 2 or 3 slides from training material, which may be helpful for you to understand connection between those terms. Yeah, this slide, you can find the slide, this slide. This is the, I should point the slide number over here, slide number 15 in module 2. You will find this slide. Now, this is overview of ICHQ2 terminology. And then on your left, This is the terms defined in old Q2R1, which was published nearly, I think, 30 years ago. So with the revised ICH Q2 validation guidance document, has much more terms defined. The reason for this is we needed to explain analytical procedure and the performance of analytical procedure and the control better by defining certain important terms. There are additional terms for multivariate terms, which was first time explained in Q14 and the Q2 guidelines. Okay, this is the terminology hierarchy in Module 2 training material. The upper layer is the technology independent part, starting from analytical target profile, ATP, and then from the mid layer and the bottom. They are terms used technology dependent situation. The mid layer is the on performance characteristics and analytical procedure attributes. Now, what do you mean by analytical procedure attributes? You need to really look at the definition of this. That is the output of the analytical procedure. We decided to name this terms attributes following ICH other quality guidelines. Now, the bottom is the analytical procedure parameter, which is input related terms of the analytical procedure. So then I think this is very conceptual hierarchy, but the upper layer is the technology independent, but middle and the bottom layer is the technology dependent terms, and the bottom is input related, and the middle layer is output related terms. Now, there is another good slide. You can find this in page 41 of module 4 in the section of analytical procedure control strategy. On your left, you have Ishikawa's diagram, which is this is the many of those analytical procedure parameter, which is input, and the output is any output of analytical procedure, something like a separation of quantitative results from analytical procedure. That is called analytical procedure attribute. So this is another good slide to understand interrelations between those terms. The module 2 has another good the slide showing the analytical procedure development to analytical procedure validation. This is actually in line with the ICH Q14 life cycle, the first part of the analytical procedure life cycle, starting with the ATP, technology selection, and analytical procedure development. So those actually description, high-level description in this slide. I think by reading this, you can understand those terms definition. With the definition from the last part of each guideline with this short sentence, you can actually follow the development and analytical validation flow. I like to emphasize the difference between validation study and the validation test. The validation study is evaluation of prior knowledge, data, and the experiment. But the validation test itself is validation test. Actually, this is deliberate experiments. So then validation study covers validation test and the prior knowledge, including development data. So next couple, 3 slides, I like to talk about the usage of development data for the validation study. Okay, so then I'm going to pick the two actually important topics, which is again validation study versus validation test, which was mentioned a second ago, and also life cycle of the analytical procedure. The first analytical procedure validation strategy. Validation study, I already mentioned the difference between validation study and the validation test. Now, this is analytical procedure validation strategy. This is slide number 15. Yeah, the analytical procedure validation is a documented study to provide sufficient evidence that procedure meets its objectives. So the naturally protocol and the report should be written. So by reading this slide, you will find out the development studies. For instance, this actually sub-bullet point, suitable data derived from development studies can be used as a part of validation data. This is this actually concept has been used most of the regions time, but some region did not allow industry to use development data for the part of validation data. So then we decide to clarify the situation. Okay, so the next slide will be, okay, this is the Annex 1 of Annex 1 of the ICH-Q2 guideline. That's also copied in Module 2 of the training material. This actually chart shows you sort of conceptual differentiation depending on the type of studies or a type of test, objective the analytical procedure from ID test, limit test, and minority or impurity test, and potency or assay. So for instance, this actually chart will show you for identity test, only specificity is typically required. Now, so this chart shows you what performance characteristics should be evaluated against the different tests. So limit test, generally specificity and the range will be evaluated. And the bottom half is the typical study type. For instance, if you look the accuracy characteristics, one of the study typical tests is spiking study. You may say this is too conceptual. Then the ICH-Q2 has the list of the 10 different analytical procedure techniques. It's in Annex 2. There are 10 of those. Each actually this is the those 10 examples is expressed in a 1-page or 2-page long table listing performance characteristics and validation test sort of high-level description, starting with the HPLC. Something like the solution was quite challenging to write to come to a certain agreement within the group. So they are typical or common techniques used analytical procedure. And then, for instance, the solution example use development data for specificity. The QNMR example employs calibration for precision. So this is fairly unique. It's quite different from HPLC precision evaluation. So, but again, each example has only one table, one page, one slide long table. So then people ask us to provide more detailed examples. So then module 3 has 4 examples selected. A separation, or I'm showing this in this slide. The module 3 part, this part of module 3 has a maybe half dozen slide long example for each technique. So I'm going to show you just some of them, just skipping through those. Okay, this is the example for validation or separation technique with relative area quantitation. This is a table, I believe this is table 3. So this is the copy of table 3 of Annex 2 of Q2. You see the list of specificity, those performance characteristics, specificity, precision, accuracy, and reportable range. And here you have a very high level of description for the validation study or validation test. The bottom box is actually included. A bottom box is, by the way, is robustness and other considerations as a part of analytical procedure development as per ICH Q14. But strictly speaking, this part is probably not the part of analytical procedure validation. However, as I mentioned, the development data can be used as a part of validation data. So then there is strong connection between validation and the development. So then we decided to include those information in ICSQ2 guideline. Now this is coming back to table 3 example. This slide just shows you the condition of the liquid chromatography procedure. This is ion exchange chromatography for charge variant for monoclonal antibody. So specificity was studied by two things. One is sample matrix interference and the stability indicator properties. Now, so let's see. I lost my. Okay. I'm just showing the specificity only, but other performance characteristics are shown in the module, but not shown in this presentation. Yeah, this is the slide for usage of development data as a part of validation data. This actually slide corrects the some of the statement from ICH Q2 guideline from chapter 2 and from chapter 2.1. So the suitable data derived from development studies can be used as a part of validation data. If the prior node is used, appropriate justification should be provided. Now, MODR, which is the design space analytical procedure version of a design space, is mentioned over here. But MODR is explained in module 2, 4, and 7. MODR is a good example for the usage of development data as a part of validation data. Next slide will show you some of the example of use of development data. I mean, I'm not going to read through this, but module 3, page 45 has this slide. Okay, now 26 minutes. The last example I'm going to show you is that the life cycle. Module 7 shows the following 4 case studies. Each case study has a full case study name, but we decide to put some nickname. The first one is impurity, second one is potency, and the third one's MIME, and the fourth one's NIR. Those actually, the nickname is used to cross-link module description in the training materials. Now, each actually, for example, each of them actually has the same logic flow being shown in this part. ATP, technology selection, analytical procedure development. Those actually logic flow is nearly identical to the life cycle chart in ICH Q14 guideline. Each case study takes about 10 pages in the text, a fairly extensive description. Because of the limitation of time, I like to show you some of the highlight the description in module 7. But the ATP I have taken from a slide from module 4 for simplicity. The first actually line bullet point is the definition, and the other description is the explanation about ATP. Next slide is the extracted from module 7 impurity case study. This is the ATP example. This is a technology. The stage ATP is defined when technology is not selected yet. So then the one thing you need to do is a linkage to a CQA. This is a stereo isomeric purity, and this is the performance characteristics which you need to evaluate. Then this is the acceptance criteria. It doesn't say which technique, but this is a somewhat general description, performance characteristics you need to evaluate, and also acceptance criteria. This is the example for ATP. Starting with this ATP and development. And this one is this is shown in module 4. It's not from module 7 example. But you will find the Ishikawa diagram as the development activity risk assessment. From on your left, the analytical procedure parameter are listed. This is looks like HPLC procedure. Then result is described in terms of performance characteristics with the analytical procedure attribute. Since I already mentioned that validation studies example, so then I skipped the validation study part of module 7. Now, this actually table 1 from ICH Q14 recaptured in module 5. This actually table is showing some technical principle with using two actually axes. One is the risk associated with the change and knowledge about analytical procedure. When or if the risk associated with the change is high or change is big or change is the complex, and knowledge about analytical procedure is low, if that's the case, in-depth study is required, and according to structured study plan. But on the other hand, risk with a change is very low and the knowledge is very high. Maybe prior knowledge would be enough to qualify change. So this is this reduction for changes principle described in table 1 in ICHQ 14. So the moving on to regulatory aspect, established conditions describe the proposed or provided by ICH Q12. I think this is module 5 of training material. Then the reporting category can be identified tools by chapter 2, including risk assessment, chapter 2 of ICH Q14, and also the table which I just showed you seconds ago. And the EC should be identified, and the categorization should be identified. So the second bullet, this one is very much consistent with the table 1 I showed you in the previous slide. The nature and the extent of EC depend on the development approach, complexity of the analytical procedure, and demonstrated understanding. So this is the same language. Well, language is a little different, but same meaning with the table 1 in the previous page. This is the module 5, the figure 2 ICHQ 14, which is already implemented in module 5 of training material. This actually, based upon risk assessment, reporting category of ECs would be 3 tiers. One high risk is the prior approval. Medium, the risk is the notification moderate category, and low is the reporting category as a notification low. Now, this actually chart can be used only when enhanced knowledge was obtained. Now, this decision tree is written based on the Q12 principles. Now, there's an important description in these two boxes, and that is to qualify changes. You need to have a sufficient understanding available to design appropriate future studies. This is the very important condition to lower the reporting category from high to medium, medium to low. This is very important. So you need to have sufficient understanding to design future bridging study. Okay, I think this is the last example slide. I mean, this is a little messy slide. I wasn't able to break up the one chart in a nice way. Just I copy paste just one chart, different portion. Oh, this is the taken from example changes from HPLC, Cairo HPLC to Cairo SFC. So those logic flow is described in module 7. But going through this, the development of the Cairo SFC procedure and the risk assessment again, risk reassessment, and then execution of analytical procedure development. Now, this actually chart coming this way and going up this way and coming down again this way. So this actually, the scenario story can be found in the module 7 impurity change to case HPLC to SFC. If you understand this technology, this is very good case study. You can study. So I think that's the last part of the example presentation. I just gave you structure of the training materials and given you just two topics only, validation versus validation test and the life cycle example. The intention was to show you how you can find the information from the guidelines, also training materials. Please look up the map of contents, and I think you will find very useful information in the training material. The next two slides is considerations. I think I said this 2 years ago here at this conference. Please use Q2, Q14 together. Never read separately. Just use Q2, Q14 together, along with the ICH Q8 through Q13. And then, yeah, in conclusion, Q14 and the Q2 guidelines establish harmonized scientific technical principles for analytical procedure over the entire procedure lifecycle. With that, thank you for your attention. Thank you very much.